In this video, we have the integral of tangent of x multiplied by secant cube of x dx. And we're going to look at two methods to do this integral here. They'll both be U-substitutions, just a slight difference. So I'm going to rewrite this as secant of x squared. This would be tangent of x, secant of x dx. And I'm going to let u equal to, let u equal to secant of x. Because then I can say du, derivative of secant is secant of x, tangent of x. This will be dx. So this right here, we got tangent x, secant x, or secant x tangent x dx. So this quantity right here can be replaced by du. That's going to be my du. And of course this secant here, that's going to be my u. So I'm just going to write this as the integral secant of x is u, and it's squared, so this will be u squared. And then, like I said, tangent of x, secant of x, that's going to be du. And then I just integrate here with respect to u. So this is going to be then add 1 to the 2 there and divide by that. So this will be u to the third over 3 plus the constant of integration. And that's the integration. We just go back to the original variable. So I just say this is equal, put it over here, and then u is secant, place the u by secant, and then that's going to be cubed. That's over 3 plus the constant of integration. I could have this in cubed, so I could write it also this way, secant of x, and that's parentheses quantity cubed. But that's the same thing as what I have there. So that's your answer for that one, using this method. Now I could also do it this way. Say this is equal to, let's rewrite it. So this will be the integral. And then this is going to be, let me rewrite it here, the secant to the third. Secant and cosine are reciprocal, so I could write this part right here as 1 over cosine of x quantity cubed. And then tangent of x can be written as sine of x over cosine of x. And then I could just multiply here cosine of x times cosine cube of x. So I can rewrite it this way and say this will be sine of x over cosine. And of course cosine of x times cosine to the third of x, that's going to be to the fourth here. So that's sine of x over cosine to the fourth. This is dx. So now I have it in this format. Still going to use a u substitution, but in this case I'll let u equal to cosine of x. Then du would equal to, and the derivative of cosine is minus sine, so this will be minus sine of x dx. So this will equal to, and then I just make the substitution here. So for this particular case here, notice I have sine of x dx here, and there's sine of x dx there. So I can actually say that sine of x dx multiplied through by a negative here. This will be a positive on this side and a negative over here. So the sine x dx is replaced by minus du. I'll put the minus out here, and this will be du, and I got it over cosine to the fourth of x, and that's equal to, and then of course the u is cosine of x, so this cosine to the fourth of x gets replaced by u, So this is actually u to the fourth. I'm going to bring it to the numerator and replace the cosine by u. So this becomes u to the negative 4 du. And then I just integrate here with respect to u. Add 1 to this exponent gives me a negative 3. And then divide the coefficient negative 1 by a negative 3. And this will give me then 1/3 u to the negative 3 here, plus the constant of integration. I'll go over here then. This is going to equal to 1/3. And then think of this. This is, remember u is cosine, and it's to the negative 3. And remember, cosine and secant are reciprocals. So I can write this as 1 over, let me write it this way, 1 over cosine to the third power here. But because cosine and secant are reciprocals, I can rewrite this as 1/3, take this up and make it a secant. This will be secant to the third of x plus your constant of integration. You can leave it the other way, but I'm just doing this so you can see that the answer that we got in the first method is the same as this one. Thanks for watching. We'll see you next time.